Hello, my name is Greg Crinklaw and I'm the developer of SkyTools. In this video I'm going to cover the basic workflow and use of doing imaging via direct control of the telescope through SkyTools. And so before we get to the telescope control part, we're going to run through the basic workflow. It's probably different than most people are used to. And it starts with selecting a target. So I have selected the target selection tool, and this is an observing list of possible targets. And I'm not going to go through in detail how this tool works. That's detailed elsewhere and in the documentation. I'm just going to go ahead and use it. I've chosen to observe the Cocoon galaxy on this night tonight, and I am going to, once I've chosen it, I'm going to go on to the next step, which is to create an observing project for it. So I'm right-clicking on the Cocoon galaxy, selecting Create New Imaging Project. And so this is step 2 in the workflow, creating an imaging project. And this is the general information. Most of this is already set up. It's got my imaging system selected. You might want to choose an imaging program. I just have the one for now, so it's just the my program. I'm going to move on to the Composition and Tiles tab. Now this is a representation of the field of view of the camera. That's the big square here. This is the object we're imaging right here. And the green stars, there's a lot of them in this case, are stars that are within the acceptable range of our auto guider. So I could keep it exactly the way it is because there's a green star within the auto guider field of view, which is this square. But I'm going to go ahead and rotate it just to see how we can do that. Moved it over here. Now we've rotated the field of view and there are 3 stars here. Now this assumes you have a rotator. If you don't, then it's just always going to be fixed, and you're not going to be able to rotate it around. There's a lot of things that are dependent on the settings for your telescope. So for instance, I said that this telescope, or imaging system really, has a camera rotator. If I hadn't, you wouldn't be able to rotate the field of view here. So if things don't work the way you expect them to, go back to the telescope setup and make sure you have everything set up properly. So we're going to move on to the, now that we've got this composed, let me show you that we can move this around as well and reposition it so we can compose it any way we want. Now that's composed, I'm going to move on to the exposure goals and filters dialog. Now I'm going to select a couple filters. Let's just go with an LRGB set. So we've selected the LRGB filters. I'm going to want an acceptable picture quality, and I'm exposing for the arms of the galaxy. I could choose the nuclear bulge if I just wanted the brightest part, faint halo if I wanted to expose very deeply. I'm going to go for the main extent of the arms. And we are exposing for a target signal to noise ratio, which this is set to 20. And we're going to use 1x binning. This camera doesn't have a variable gain, so there's just one gain selection. And we're going to set the minimum acceptable quality to excellent. And that's pretty much all we need to do. I'm going to go ahead and click done. And we've created an imaging project. You can see the P here for this galaxy. So the next step is to move on to the scheduler. Move on to the scheduler. It's already set for tonight. It is going through all the imaging projects right now. Here we are. There's a couple galaxies here. I'm going to start with M109. If you look up here, this green period, this green band here, is the best time of night to observe this galaxy that I've selected. And down here, this is what it's going to choose under the current conditions and selections. To observe. It's going to do 3 8-minute exposures in the red filter, 3 570 exposures in the blue, etc. I'm going to look at a different galaxy here. well, we'll go with M109. So I'm going to go ahead and just double click on it, and that will add it to the schedule. And then there was the galaxy we were looking at, which was the Cocoon Galaxy, and I'm going to add that to the schedule as well. It put a little gap in here. I could select another object and maybe observe it through this gap. This line here, by the way, is the schedule line. I've given, in order for debugging, I've given it huge, long, crazy 10-minute times in order for the mount to flip the meridian. This is on a gem mount because I was testing it. So these red lines here are when it's slewing to flip the mount, but usually they'd be much narrower. So the red here is slewing to the object. Then this is the first observation, the second observation, another slew, actually a flip, another observation, a slew, more observations. And these are all marked over here, and you can see if I select them in the schedule, it will select what I'm looking at. And meanwhile, for the object, this is these colors here tell us the best time to observe, and as with the night bar in general here, this red dashed line is the altitude of our selected object. You can see that the best time to observe is when it's high in the sky and before the moon comes up, which is this teal line. Okay, so I didn't want to go into too much detail. We've created a schedule here. So now we go on to the next part. Now, so we did three things. We selected one or more target objects. We created imaging projects for those objects, which sort of define what we want to observe and how we want to observe it. And then we picked a night, in this case tonight, and created a schedule for that night for this telescope. So now we're going to go out and we're going to observe these objects. And so I'm going to click on the real-time imaging tab here, and I'm going to select May 4th. So this is the night tonight. Okay, so I had a glitch there. In fact, a couple of glitches. The first thing I noticed is that, select our project here, that it's not reporting the position angles of the camera over here. It seems to have decided that this camera no longer has a rotator attached. I'm going to have to fix that. The other thing that happened was entirely connected to the fact that I'm cheating. And I'm not actually out at the telescope. I'm using a simulator. It's the middle of the afternoon. I've tricked SkyTools into thinking it's later into the day, but the scope simulator still thinks it's the middle of the afternoon, and that leads to some interesting little glitches. So this is why this is something that really needs to be tested at the telescope when you're actually imaging. It's very difficult to cheat and play with it, say in the middle of the afternoon. Okay, so this is the real-time tool, and this is where we observe the schedule we created with the scheduler. And normally you would observe the schedule that you made for that particular night, which we made it for May 4th. Here's May 4th. And this is the schedule we created. So why do we let people choose different nights? Schedules made on different nights. Well, the answer is, let's say you're observing very near full moon, new moon, sorry, and you've got this big, long, detailed schedule, but it was cloudy. And the next night, almost nothing has changed. Changed by a few minutes around the twilights. The moon's not up, there's nothing else going on. Why not use the schedule you already created for the previous night tonight? And that's why you're allowed here to select a different schedule that was created for a different night. But in general, each night is different, so you want to use the schedule that was created custom for the night that you're observing. Okay, so this here is telescope and time information. Up here we have our night bar. The thing to watch on the night bar is this vertical line. This is the current time. Here we have our schedule blocked out. The red blocks are when the telescope is slewing or flipping, and the green blocks are when it's exposing. So this matches the schedule down here. The first slew is to M109 at 2124, and that's at the beginning of this red block. Now, why is this red block so long? It doesn't usually take 13 minutes to slew to an object, at least I hope not. And that's because in testing, I set the Meridian flips to be 10 minutes long so that I could follow them and see when they appeared and make sure they were working properly. Hopefully, if you have a German equatorial mount, your Meridian flips don't take 10 minutes. Okay, so the next thing we want to do is, presumably we've prepared our telescope, we've aligned it, we've focused it, we've done all the things we need to do before we start observing. The thing we want to do here is set up our defaults for when we log our observations. And I'm going to say that the seeing is fairly good tonight, about 1.5 arc seconds. I looked at some images while I was focusing. It's 40 degrees out and the relative humidity is 25%. Okay. The other thing I can set here is the image quality. I'm going to set that to very good quality. I'll just leave it there. The purpose of that is when we log our observations, we assign it a quality, and that's just something that you feel describes how good the image is. And that is used when we look at whether or not an imaging project has been completed. We make an observation. If the quality isn't up to what we've decided we want as our minimum quality, let's say the quality is unacceptable, then it won't count these images that we've made towards the completion of the project. Because one of the things that SkyTools is doing with that imaging project that we created is keeping track of your observations and deciding when we're done. No, we need 3 more images in the blue filter. Red filter's finished. It'll do that sort of thing. So the next time after we've observed that project, we go back to the scheduler, it will only schedule the remaining observations. Ultimately, there will be no observations left, and our project will no longer appear in the scheduler. It's complete. Sometimes people want to delete their projects when they're done, but that's not what we're doing here. We're completing those projects. That means we can still look them up. We can find out what we did, what images were taken, what the conditions were that night. It becomes an archive. But it's not going to appear in the scheduler anymore because we finished it. So I'm going to set the quality to very good. Looks like it's a pretty good night tonight. Everything's working well. Okay, so we're ready to start observing. I'm going to connect the telescope.
Telescope connected.
And then I'm going to click the Start Imaging button.
Telescope slewing to target. Telescope slew complete.
So it turns out it was already pretty close to that position. So what it's doing is it's observing this schedule over here, the schedule that you already created in the last step. And it went ahead and slewed. We're pretty close to the time we're going to start observing, which is 21:37. It's actually in 16 minutes from now. So it went ahead and we're within 10 minutes of that. It went ahead and slewed to that first object. So beware that this will automatically slew your telescope from object to object. So make sure you're aware of that. Okay, so it has selected the first observation. We're on M109. If I needed to, I went and adjusted my field. I got everything centered the way we want it to be. You could use the interactive atlas for that. Not really set up for this, but I'm going to be brave and go ahead and click and see what happens. So here's the center part of the interactive atlas. This is the observation we set up. This square here is our guider. You notice it's on a nice guide star. This is our target object. As we go on, it will move from object to object, so we can follow it here. And also I can bring up the camera window, and this creates a preview of what we should see in the telescope. Now notice some of these stars have these funky red lines through them. That means that they have saturated, and because they're too bright, you may see spikes on these stars. Excuse me. So if you need to manually set the position of the telescope once it's slewed, maybe it was over here, you can use this to tell you where it's supposed to be, recognize the field, manually move it back, and once you're there, you're ready to go. I'm going to go ahead and close that, and we're back to our observing situation here. Okay, so we're all ready to go. I'm going to now program my camera. I'm going to set it for the red filter. I'm going to set it for 8 minutes with 1x binning. This would also often tell us what the camera rotation should be if I told it that I had a rotator, and that's the rotation needed to put that guide star right in the middle of the field of view. Okay, so I've got my camera all set. I click, I tell it to start exposing. And I come back here to SkyTools and I click this button.
Started.
And that tells SkyTools that I have started the exposure, so it can keep track of what we're doing. We're doing 3 8-minute exposures in the red filter. That's what we're doing right now. And a couple of things that I didn't go over. I've done this several times now, and I've sort of lost track of what I've talked about and what I hadn't. Up here on the night bar up here, the red dashed line is the altitude of the object, M109. The blue line is the quality of imaging. We want this blue line to be very high. Right now it's very high. And so this is a really good time to image M109 on this night. It's not going to be so great later on tonight, say at 2 a.m., once it's gotten lower in the sky and the moon has come up. So now's the time. This right here tells us a summary of that same observational quality. It says the best time of night, the A period, is this bright green area here. So we could have started observing earlier, and we can continue to observe this object in this filter past midnight. But in our schedule, we decided to start here and finish the filter a little after 2200 and then go on to the next filter. Okay, so we're still exposing that first 8-minute exposure. We're not going to be here all night doing this, so I'm going to go ahead and cheat, and I'm going to just assume that the camera has closed its shutter, read out the image. We're ready to take our second of 3 8-minute exposures in the red. So I click on the camera, control, and I tell it to start an exposure, and then I come back here and I click here.
Started.
So that tells SkyTools that I've started the second exposure to keep track of things. And similarly, I am not going to wait for it to finish that exposure. I'm going to go ahead and click.
Started.
Now, this button here has changed to log image set, and that will happen once we have started the third, or in this case, the third and final exposure. And when we're done, when the camera has finished reading out the image and everything is done, we can go ahead and log our set of 3 8-minute images. So I'm going to go ahead and click that now, even though it's not done. And that brings up the observation dialog here. This is a standard dialog in SkyTools for logging your observations. Everything's already filled in for us. The location, the filter, date, time. This date and time came from when I clicked the button over here. So it might have been a couple of seconds after I started the exposure, but if you don't care about that, then you can go ahead and use this as the date and time, or you can change it. Or you could go ahead and click Read Fits Header, find the image on your computer, and if your camera creates images with fits headers with lots of information, you can go ahead and read that information in from the fits header for the first image in the set, and it'll all show up here as well. So we've got very good quality came from there. The weather came from our settings here. Once we have things set up, we can really just go ahead and click OK. Okay, so we've logged our first set, and now it's telling us to go on to the next set. Now really it says that's not for another 36 minutes. But I'm going to go ahead and pretend that I'm starting that next set. And so I go into my camera control and I set it for 570 seconds. Okay, I set it for the blue filter, binning times 1. I start the exposure, I click the button. Okay. Then when it's done, I start the next exposure, click the button.
Started.
When it's done, I start the next exposure, click the button.
Started.
Okay. And then just as before, I go ahead and log this set of 3 570-second exposures. It's all here. I'm done. Click. And it has moved on. Now, the exposure, or the scheduler put in a Meridian Flip here. It didn't perform that Meridian Flip. Why? Because it doesn't need to, because we're still back early in the evening because I cheated and didn't actually take all these long exposures. So we haven't moved late enough into the night that it needed to do a Meridian Flip. It's not going to do a Meridian Flip just because it's in the schedule. It'll do it because it thinks it needs to do it. And this is something I'm going to need a lot of feedback on. Hopefully it's going to work properly. But it's very difficult for me to test it with the simulator. The simulator doesn't have things I can set for the limits of the Meridian Flip. And we should probably talk about that real quickly here. I'm going to go back to the place where we set up our imaging system. I'm going to click Gem Limits. This is where you put in the limits. If you need to flip your mount right at the meridian, you'd put in 0 degrees and 0 degrees. There's an east limit and a west limit. So that's what I've set here. And for some reason it stopped running. It's another thing to fix. Okay, so, but that brings us to the next feature. Let's say the clouds came in and I had to stop. Well, I just click stop. I'm done. Okay. I go find something else to do for a while. It's later in the night. And look, magically, it's now later in the night. Okay, so here's our schedule. It's now after 11 o'clock. And we should have moved on to another object. Hey, it's cleared off. Okay, my telescope is up and running again. Everything's ready to go. I'm going to click the Start Imaging button. And now it's moved on to the next observation, which is based on the time on the clock, which is the first observation of the Cocoon Galaxy. And I'm going to go ahead, it doesn't want to slew yet, but I'm going to go ahead and click slew now.
Telescope slewing to target.
Now if we followed this through normally and followed it using
telescope slew complete,
the correct times, and did the actual exposures, when we finished a set for a given object, it will just take off. It'll automatically move on to the next object. You won't have to click the button. It's only because we're cheating that we click the button. So in case you missed it there, if you have to stop at any time, you can click the stop button, and then when you click it to start again, it will pick up in the schedule wherever is appropriate based on the time of the night. So I could go ahead and observe the Cocoon Galaxy. Let's look at it in the atlas here. So here it is in the main atlas. You can see this cursor here is the position of the telescope. And here's the camera view. So I could go ahead and go through the same procedure, and when we get done, it'll just automatically stop, and we're done for the night. These are the observations we had planned. So that's how you use this. There will be another mode, as I mentioned before, I think, where you can observe more on the fly. You don't have to observe the schedule. You basically sort of make your schedule as you go along. But it'll work very similarly. You'll schedule one imaging project at a time. So like here, the M109 observations. And they will appear there on the right side, and then you will observe them. When you're done observing them, you go back and you pick a new imaging project. That makes it very flexible for weather or problems. I mean, we all know that we start observing and everything's great, and then things break. And then we get things working again, or the focus goes out, or whatever. And then we need to start up again. I think a lot of people will like that mode. I will have that mode available in the next update to test. Okay, so I think that's everything. I do want to go and look at an imaging project. So I'm going to go to Tools here, bring up the Project Manager. We were working on M109. So here's our M109 imaging project. Notice it brought up the Observations tab automatically, and that's because we made observations for it. Here are our logged observations that we made. Okay? And based on that, it determines whether or not we've completed the project. And I'm going to set this to good. I had it set to excellent. And now it's telling us that we have completed 2 of 2 for the blue filter, 1 of 1. Basically, the whole project is completed. And this gives us the signal to noise ratio that we actually achieved. Everything is completed at 100%. So when I click done here, we're going to not see this imaging project again because it's completed. If we want to do M109 again, we'll have to create a new imaging project, or we can go back to the Basic Properties tab here and click Duplicate. But normally we want to change some things. So let's say we wanted to look at an observation. I'm going to double click. This should look a little familiar. This is where we enter the observation. So here's all the information for that specific observation. We can add images. Let's say it's a FITS image, and there's a blue FITS image. I click here, I open the image, I can make it plottable, so that image will appear in the background of the interactive atlas or the other charts. And assuming that it's been plate solved, it will have to be plate solved. Someday SkyTools will have a plate solving capability, but right now it doesn't. So you need to use another tool to plate solve it. Anyway, so then you will have a complete record of your observation, and I'm just going to go and close these things. So there it is. That is the whole process of SkyTools 4 when you're directly controlling your telescope. So thanks for watching.